All right, so we talk about the human ear today. On page 357, your textbook is where you might want to find some of these diagrams and things. We just watched the 3D video, so I'll go back to that. I did pause it at this graphic right here. So javits3d.com is where this sort of comes from. And we watched an animation of how the ear works. And yes, the comment was just made that it is amazing how intricate and how incredibly designed our hearing is, especially inside the ear, like these fibers that vibrate only at certain frequencies. So when it says that some of these fibers have a resonant frequency, that means they move when they perceive a certain frequency of sound. Rooms have a resonant frequency. So if you were to play a sound in a room, and if you're a musician, you've probably heard this in a practice room before, but if you play a certain sound on a guitar or on a piano or on a bass, is where it really, if you play a certain note, it seems super loud in that room. That means that there's a resonant or an inherent sort of frequency of the structure of the room. So that means that the whole room vibrates at that frequency, and so that's why it makes it louder. So that's what happens here. Only certain fibers vibrate when they feel or when they sense their own frequency. Transmits that energy into those little fibers, those little cilia in your ear that wave in the fluid. They wave and they send these electrical impulses to your brain. And then it goes from there and your brain interprets that.
Where are the fibers?
The fibers are in a structure called the cochlea. And we're going to be talking a lot about these little structures. So here's the eardrum. This is a little bone. The tiniest bones in your body are these three that are connected amazingly intricately. The malleus, the incus, and the stapes right here. And basically this cochlea is wrapped up sort of like a seashell almost, but it's wrapped up in a coil. There's sort of very viscous fluid in there, and that fluid, when this little stapes bone taps on the side of the cochlea, it causes like ripples, waves in the fluid, which then engages all these little inner workings. All these semicircular canals too, we'll talk about those when we get into the diagram. They have an important function to play in our balance and things like that. So the inner ear, which this would be the inner ear, is incredibly well designed and complicated, and did not happen by chance, I would venture to say. Did not happen by accident. This was a very well designed system. Comment, question?
Those bones, they seem really easy to break.
Yeah, these bones are the tiniest bones in your body. And remember, so this is roughly to scale, I believe. This is 1 centimeter right here, your eardrum. 1 centimeter only. So these bones are probably like a 1 centimeter-ish, and maybe 1/3 of a centimeter, right? So millimeters. They would be very easy to break, but yes, they would be very easy to break because they're little and tiny and very intricate. However, they are buried deep within your head, and they are surrounded by tissue and fluid and supporting, things like that, flesh, right? So yeah, so it's hard to get to them. And even this eardrum is quite a ways into your ear canal. It's very hard to actually get in there with anything and puncture. I mean, you could do it, but anyways, it's not easy. Okay, any other questions, comments on this so far? Yes?
If your eardrum breaks.
All right, so let's take a look at our notes here. So you should have these notes in front of you. This is a diagram similar to what you have in your textbook, and we'll take a look at that as we move through here. But let's fill in some notes on the incredibly designed and very intricate human ear system. All right, so 11.6 on page looks like 3 of your notes. The human ear consists of 3 sections. 3 sections: the outer ear, the middle ear, and the inner ear. Okay, so as far as our blanks go, it's going to be outer ear, and roughly the outer ear is basically your earlobe and some of your ear canal. Okay, so here's the outer ear. It's the earlobe that you can see and feel, and in that video too, your ear is specially designed in such a way that it collects these sound waves, and literally it kind of funnels the sound waves in to your ear. It's incredible. If you do this with your ears like this, you can hear people better because you're collecting more sound waves in your transfer. You can also hear yourself very much louder. Have you noticed that? Okay. Why do you hear yourself so much louder when you do this? Anybody, any ideas? You're collecting maybe some sound energy from the outside too, but I would say that the vibration of your head too is now being transferred into a larger connected structure that makes your inner ear vibrate some more. So even though, I mean, I'm hearing from my voice out the front when I do this, you hear yourself much louder. But another thing to do is if you're in a spot, I don't know if you've ever want to try this, but if you like cup your hand like this, put them together, and then connect your mouth right to your ear, you can incredibly amplify your voice. You can almost whisper, and it's like you have headphones on and you're hearing a very loud recording of your voice. So just kind of cup like this, and then just try it. It's like hello. Yeah, you don't want to cover you can't cover your face like that, but just like this, you hear it's like incredibly loud, right?
It's like the great one banana phone.
Yeah.
We used to get to like silent read, and we'd have like a little phone. And
Yeah.
like this, and you can
You used to have like a little phone in class where you can like read to yourself. That's funny. Look at this big banana structure. Yeah, like this. There you go.
It was grade 1.
Grade 1?
They
Beauty.
experienced it.
Wow.
You remember grade
That is awesome. Banana phone. Bump, ring, 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 banana phone. Okay, you guys know that song? Good old, was that Fred Penner? Okay, I digress. All right, outer ear, middle ear, and inner ear, okay? Okay, so the middle ear, roughly, the middle ear are those really cool kind of malleus incus and stapes, eardrum, cochlea. Well, middle ear would be the bones, I guess. The inner ear here would be, your cochlea, semicircular canals, I guess, in there. Also, the auditory nerve, okay, that all these impulses are sent to the brain through the auditory nerve, which is amazing, really cool as well. So outer ear, middle ear with the bones, more or less, and then the inner ear with the cochlea and semicircular canals. Okay, so the outer flaps of skin and cartilage act to reflect sound down the ear canal. So your blanks there. No blanks on that first one. Awesome. The ear, canal reflects sound down to the eardrum, or also called the tympanic membrane. Okay, the eardrum, the tympanum, the tympanic membrane is that eardrum structure. Okay, the ear canal protects the ear from injury. Obviously, it's tough to get things down in there to perforate this or to mess up your inner ear. So the distance here, I'm guessing it's 4 or 5 centimeters, really. I mean, or so. So it's enough that if you accidentally get a finger poked in your ear, it's not going to go into your inner ear there, making it difficult to touch directly. Also by, this is cool too, also by secreting. Where am I at here? Secreting a wax that catches dust and bacteria to keep the eardrum clean. So earwax, I mean, if you have lots of earwax, buildup of earwax, some people do, it's something that your body naturally generates, but it's for the purpose of this. It generates this earwax, and it's meant to flow out of your ears because it's sticky and gross and whatever, but it catches dust and bacteria that's trying to work its way into your inner ear. And sometimes you have an ear infection, right? If your ear hurts, you have an ear infection. Okay, things get in there and mess up your inner ear. But the mucus, the ear wax, is supposed to pull things out. And when you shower or wash or whatever, or maybe you have to kind of carefully remove some of the wax near the exterior, that is just like your mucus in your nose. Like when you have a runny nose, your body's saying, hey, there's some germs or some sickness or whatever, we need to secrete. Let's get this stuff out of our body. It's why you blow your nose. It's why you have a runny nose when you're sick. It's trying to secrete all the garbage out. So that's what happens to your ear naturally. Yeah, obviously very slowly. You don't have to blow your ears like you have to blow your nose. Thankfully, right? Sorry, I'm just gonna blow. You don't have to do that. Yeah.
What are the little yellow dots?
The little yellow dots in the diagram, that would be just cartilage, flesh, that kind of thing. There's blood vessels and all sorts of different things there, yeah. But I guess it's just kind of saying these aren't sitting in space in your head, right? Even if someone calls you an airhead, you're not an airhead, okay? No matter who you are, you have actually flesh and that in your head, okay? Maybe does anybody say that anymore? That's really mean, but that used to be like a common term when I was a kid. You airhead, like you got no brain, right? It's just space in there. You airhead. Don't say that. It's not good to say that.
grandpa was in a car with his wife, and
The middle ear, the area between the eardrum and the oval window. So between the eardrum and the oval window, I suppose they would call the oval window would be here. So this is the eardrum and the oval. I'm sorry, that's the outer ear. oval window. Is it on this one? Interesting. Okay, so it's in between here where you kind of the cochlea and that. So it's in between here. This is the middle ear. The vibrations of the eardrum are transferred from the outer ear to the inner ear by movement of 3 very small and fragile bones. So the vibrations of the eardrum are transferred from the outer ear to the inner ear, 3 very small and fragile bones. Malleus is the first one. Now, there are common names for these as well. You'll have to remember both, but malleus is the hammer, okay? It kind of looks in the diagram. It's really tough to see on that one. Let me see if I can go back to, yeah, here we go. So this is kind of like the hammer, okay? Got a handle there, and it's got a hammer. That's kind of looks like a hammer, malleus, incus. This one maybe more looks like a hammer, but this is the hammer, okay?
Oh, because it's a mallet.
Yeah, maybe, because mallet hammer as well, for sure. Gets the vibration from the eardrum. Yes?
So if you were to like tear your eardrum, does it like fix itself?
Well, we had a discussion earlier. If your eardrum is perforated, there's probably a good chance that it will repair itself. But it's so small, there might be scar tissue and stuff in there that might affect your hearing. Still, I don't really know. That's a good question. You have to ask a doctor. I don't know if you know one. Okay. Okay, so the incus is the next one. Let's see. Oh, malleus, you got to write that down. Malleus, mallet, hammer, good idea. Remember it that way. Incus, okay, incus, that's the anvil. So an anvil is like a hard metal structure that you would, hammer onto. So that's connected, hammer, anvil. It transfers the vibration from the malleus to the stapes, and the stapes, which is called the stirrup, and that's simply because it looks like a little stirrup, right? It's kind of like almost circular there, like a stirrup on a horse saddle. So it's the stirrup. What? Like a stirrup. Not syrup. No, not like you're mixing syrup. Stirrup. Okay. Did you hear me say syrup? Does it sound like I said syrup? Stirrup. Okay. For all you non-Western people out there, okay. No, well, stirring the syrup. However you remember that, you just be you, okay? That's fine. So the stirrup presses against the oval window, okay? Presses against the oval window, which I suppose technically now this oval window would be, the contact point of the cochlea, okay? That coiled structure there. So it presses against the oval window, transferring vibration to the inner ear. So the middle ear also contains a tube connecting the inner ear to the sinuses. All right. This allows for balance of air pressure between the outer ear, and the middle ear to remain the same. This is why swimming to the bottom of a pool hurts your inner ear. You feel that pressure. Or if you're driving, you're driving down into the valley or something, okay? Because of the air pressure that's now piling up on top of you, there's more outside pressure and you feel that pressure. Or if you're flying in an airplane and you're ascending very quickly, there's a change in pressure. So there is a tube connecting your inner ear to your mouth, and when you swallow, and if you're chewing gum or whatever, if you swallow like that, like just swallow, like, you'll hear a little crunching sound in your ear, and that's just this little this tube opening and closing to balance the pressure from outside to inside your head. Okay. Okay, the other thing that should be said too is when you have a cold, remember I said earlier, if you have a cold, your nose runs, right? You have to blow your nose. Also in your sinuses, right? That mucus is building up, getting thicker, and is running a little bit more. So that's why sometimes when you have a cold, you kind of sound like this. I have a cold, and I sound funny. I have a cold, like that. Okay, that's because that tube is plugged. Like it's not, like you're not actually getting that free flow of air and stuff like that. So when it's all plugged inside your sinuses, it's literally, you sound like you hold your nose, and that's what you sound like we have a cold, because you're blowing your nose. It's like, oh, my sinus pressure, I can't, mucus plugging. Yeah. So that's why you sound like that too. And that's why sometimes your headaches and stuff like that, when you have a cold, because that's plugged, the pressure is building up and you can't release it very well. Okay. All right. We have a couple paragraphs here yet to go. Let's finish the notes here in this section, and I'll give you some questions to do. The inner ear. Okay. Where's the inner ear? The inner ear, everything between the oval window and the brain. So if we go back to our diagram up here, it's tough to see on the side, but the cochlea, the semicircular canals, which we'll talk about later, and then the auditory nerve to the brain. That's the innermost part of your hearing system. That's called the inner ear. Brain is a blank. Good. Our brains are a blank. That's sad. The oval window is like the second eardrum. It's moved by the stirrup bone and vibrates the fluid that fills the basilior membrane in the cochlea. Okay, so we definitely have blanks highlighted there. So yeah, it's like I said, I guess it's the space that that stirrup kind of taps on the cochlea there. It's that space there. The cochlea, funny word, but it's pronounced cochlea, is made up of the basilar membrane wound up in a coil resembling a snail. Okay, right here, resembling a snail right here. It also connects with the auditory nerve. Now, if you watch this, if you watch the video, right, that video that we watched at the beginning of class there, it shows you this uncoiled and kind of takes a look at inside where there's all sorts of amazing things that even just this vibration of fluid has certain frequencies which triggers these fibers in your inner ear, making your little cilia wave and transfer electrical impulses to your brain. It's amazing. Okay. But the basilior membrane is a tube with a continually diminishing diameter, so it actually kind of starts thicker and it gets smaller as it's coiled up. It's lined with hairs or little cilia that move in response to different pitches or frequencies. Over time, the hairs break off and the ability to hear that frequency vanishes. And so as I mentioned before, sometimes when you age, the higher frequency seems to go first. So those little hairs that respond to the highest frequencies. And I guess that would make sense because they're waving around the fastest almost, right? It would seem like they would jiggle the fastest sort of thing to transfer that energy to your brain. And so they might just get worn out a little bit quicker. I don't know. Jiggle? You don't like the word jiggle?
I hate it.
Really?
It's so bad.
It's a weird word, yeah. Like it's
Say it like
like jiggle at times makes me giggle. What about giggle? Is giggle bad?
Jiggle go. Jiggle go.
I don't know. What do you think? Jiggle bad? Do you like jiggle?
Moist.
Do you like jiggle? Okay, we have some votes for jiggle. I don't know where that came from. Okay. Any questions so far other than about the word jiggle? All right. So I'm going to do this little YouTube video here next. Can you trust your ears? Just let me just go to one thing here. So as well, here's the videos online if you want to take a look at. We're going to do these, Trust Your Ears, Yanni Laurel. That one, and then the video that we did today will be up there as well. Okay?